You will need to perform these steps to complete this example. Let's get started. First, import the model and initialize the simulation. You can start this example by importing either SOLIDWORKS geometry or 3DEXPERIENCE native geometry. You can use the SOLIDWORKS connected app to store native SOLIDWORKS assembly and part files to a collaborative space on the 3DEXPERIENCE platform. A collaborative space is an area where people with different job functions in your organization work together to produce and deliver content. After you open the bracket part file in SOLIDWORKS Connected, you save it to the 3DEXPERIENCE platform. When you save data to the 3DEXPERIENCE platform, it saves the data in the active collaborative space. The name of the active collaborative space is visible on the right-hand side of the menu bar. You can change the active collaborative space without logging out or closing the active session. You can use the linear structural validation app to perform structural stress, buckling, frequency and thermal simulations. To help you define and run a simulation, you can use the Assistant. Right-click an empty section of the 3D area, and select Assistant to open the Assistant. Next, apply a material to the bracket. Click the material definition for alloy steel, and drop it onto the part in the 3D area. The green check mark indicates that you satisfied the minimum requirements for materials. Next, apply boundary conditions. In this example, you assume that the bracket is attached to another component using two bolts that are not included in the model. Therefore, you apply a clamp to the two bolt holes to restrain the bracket's movement. A clamp is a type of restraint that restricts all degrees of freedom for the chosen geometry supports of your model. Next, apply a pressure load. In this example, you apply a pressure load of 1000 psi to the flat circular surface of the cylindrical feature. The pressure distributes a uniform load normal to this surface. Next, run the simulation. Running the simulation predicts the behavior of the bracket in response to the applied pressure. You can use the simulation status window to monitor the progress of your simulation and diagnose errors. To reopen the simulation status window, click Simulation Status in the Standard section of the action bar. Next, analyze the results. In this example, you examine the results plots for the von Mises stress and the displacement. The maximum stress occurs at the corner beneath the cylindrical feature. The maximum von Mises stress is higher than the material's yield strength. The maximum displacement occurs at the top of the cylindrical feature. Next, assess the factor of safety. In this example, you review the factor of safety contour plot to display regions of the model that are nearing the material's yield strength. The app uses the Johnson-Cook material parameter of the alloy steel material definition to calculate the factor of safety. Regions of the model with a factor of safety less than 1 develop stresses above the material's yield strength under the current loading conditions. As it is expected, the smallest factors of safety occur in the localized regions where the highest von Mises stresses occur. Next, remesh the part and rerun the simulation. The Mesh Specifications dialog box displays the product structure and associated mesh specifications for each part body. In this example, you decrease the mesh element size to 5 mm, and then you remesh the bracket. After rerunning the simulation, you review the von Mises stress plot to confirm whether the maximum values converge to an upper limit, or keep increasing, indicating stress singularities. Next, compare the stress results. You compare the stress results from the first simulation that uses the default mesh to the stress results from the second simulation that uses the refined mesh. The maximum stress at the corner of the base plate increased. When you refine the mesh, the stresses stabilize as you move further away from locations where stress singularities occur. The bracket stress hotspot remains lower than the material's yield strength. Finally, bookmark and share the results. You can create a bookmark for the structural simulation object, and you can share the bookmark with your team to facilitate communication between team members. Your team members can review the von Mises stress throughout the model to ensure that the maximum values are within the acceptable operational limits. Enter the descriptive title that you gave the simulation. By clicking Create, the app creates a bookmark of the physics simulation object. The designated team members can access the bookmark of the simulation object using the Bookmark Editor app, which lets them organize and manage their data. Congratulations! You successfully completed this example.